All right, so today we're going to take a look at the beginning of Chapter 4, Lesson 4.1. Before we get to that, take a look at your problem of the day, pause the video and solve it. Now, we officially start Chapter 4. Chapter 4 deals with quadratic functions. And what do we start off with first? 4.1, graph quadratic functions in standard form. All right, standard form. First things first, what does that actually represent? Standard form is going to be in the form y equals ax squared plus bx plus c. So standard form, we now finally have x squared. Up until this point in Algebra 2, we've only talked about x to the first power. Now you might be saying, all right, well, it's a square now. Well, what does that look like? A quadratic function looks like, or what it's called is a parabola. And parabola is this U-shaped kind of shape that you'll take a look at in a minute. Parent function for quadratic functions, y equals x squared. We're going to start with the vertex at 0, 0. So the vertex is going to be here. And actually, that's where our axis of symmetry is. It's a vertical line through the x coordinate of the vertex. So axis of symmetry, x equals 0. And I mentioned it's a parabola. It's a U-shaped graph, something like this. It's symmetric from each side. So we start with a problem by just making a table here. And with the table, usually I'll tell you to try at least 3 points. You could do 5, you could do 10, you could do whatever you want. Actually, anytime that we've been graphing thus far in math, really, if you forget a method to graphing, whether it's a line or a parabola or anything else, you could actually make a table. So I'm going to make an XY table. A little more room between them. I'm going to use the points -2, 0, and 2. A little line between them. You might be saying, why am I not picking -1, 0, 1? Remember, you can pick whatever you want, but you see because of that half here, with the half, we're going to get a decimal, and I would just rather stick to like bigger numbers and count by 2s to not have to deal with the decimal. That's just me. So when we solve, don't forget, I'll plug in -2 first, but you're actually plugging it in with parentheses. And also, don't forget when you're evaluating, we square first. So I'm going to actually write the first one out for you. I won't show all 3 of them, but to refresh your memory, we square the -2 first. Quantity -2 squared is 4. And then 1/2 times 4 is 2. So take a minute, plug in 2. Take a minute and actually solve the rest of them, and then we'll plot them. So you might want to pause the video to try them out first. Here's my table. I'm going to plot my points. -2, 2 is here. 0, 0 is here. 2, 2 is here. You notice my axis of symmetry is through x equals 0. You saw it with the parent function one, right? From the previous slide, we talked about it being a dashed vertical line through 0, 0. And actually, our vertex of the parabola is 0, 0, right? To the point 0, 0. That's the same as the parent function that we took a look at. We'll just connect all the points. You see it's symmetric. It's a U shape. Parabola. Now let's take a look at, I'm going to go back for a second. At the bottom I said, what did A do? And it might be harder to see with this one, but if you notice a little bit, this is slightly wider than the last one. So A actually makes parabola wider. We'll take a look at that in the next slide. So properties of the graph y equals ax squared plus bx plus c. Let's talk about what happens here. The graph will open up if, slide this up here for a second, if a is greater than 0. The graph will open down if a is less than 0. So let's take a look back at the previous one. A is greater than 0. What's my a? My a is the number in front of the x squared. It's 1/2. Positive 1/2, it opens up. If a is negative number, it will open down. Narrower is going to happen if absolute value of a is greater than 1. And it'll be wider if absolute value of a is less than 1. All right, the y-intercept is actually going to be c, the c to the quadratic. Now, to sort of talk about this, I'm going to take a look at, so if we take a look at like what I started to say, an actual function of a quadratic, I said the graph, let's revisit what we talked about the properties to show you guys a little bit more. How to tell if it opens up or down. If a is greater than 0, it opens up. So what's my a? A is 1. And actually, this is our standard. You see it's y equals x squared. So let's see what happens if a is greater. See, it's all positive. We flip down. Here's my negatives. If a is a negative number, it opens down, right? Does everyone see that? All right, so let's start with the next part because wider or narrower can be very confusing. It says the graph will be narrower if absolute value is greater than 1. So it doesn't matter what sign it is, positive or negative. It's an absolute value, but greater than 1. So take a look at what happens when it's greater than 1. See how it gets narrower and narrower and narrower? Let's go over to a -1. Hold on one second. Narrower, narrower, narrower. All right. Let's go back to the original. What happens if it's less than 1, the absolute value less than 1? Wider, 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 wider. Okay, let's go to 1 over -1 over here. Less than, wider, 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 wider. So did you guys see that? Now we said the C. Well, let me get back to my standard here. C, if I move this, here's 3. What do you notice? It's at +3 along the y-axis. Let's go to -5. Where's the C? At -5. So the y-intercept is C. All right, it's where it cuts through the y-axis. Now we talked about what happens with A, all right, which was like the slope. And actually what's interesting about A, if you actually remember, is this is the same thing with absolute value graphs, wider or narrower, opens up or down. Absolute value graphs are the V graphs, right? C is the y-intercept, but we didn't talk anything about B yet. So B is a little more complicated than that. So let's take a look at what happens with B. So right before we talk about B, let's look at example 2 to answer this. What would you expect the graphs to look like? We had 3 parts here, right? So let's see, number 1, from the previous slide, my A is what? A is in front of the x squared is -4, -4 is less than 0. So it's gonna open down, all right. Next part, we have to do the absolute value of A. Remember, once again, A is in front of the x squared, which is 4. So it's always positive. 4 is greater than 1, so it's narrower. And then C, I don't have any number. You see how there's no B or C? C is just going to be 0. So my y-intercept would be 0. All right, let's do it the same here. You might want to pause the video and try to do it yourself. Now, hopefully you pause the video to solve it because I want you to take a second to try yourself. Here's what we get. 1. My a, which is the number from x squared, is negative 1. Negative 1 is less than 0, so it opens down again. Now, what's interesting that happens with the next one is if you take the absolute value of a, absolute value of negative 1 is 1. 1 equals 1. 1. It's not narrower or wider. It's actually the same. Then my y-intercept is c, which is negative 5. All right? Now, we mentioned what happens with b. All right, here's our standard form. And once again, don't forget, a is in front of x squared, b is in front of the x, c is the number by itself, a constant. So let's talk about b. B works with a to provide the x-coordinate of the axis of symmetry. We're going to use the formula x equals negative b over 2a. So now what we're going to take a look at is finding the vertex. All right? So what we do first is we're going to plug in our numbers that we need. And actually, I'm going to label them right here. A we know is 1. 1's in front of x squared. It's understood if it's not there. B equals 2. It's the number in front of x. And c is the number by itself. So let's just label these all first. All right, so I'm going to plug it into x equals negative b, so negative 2 over 2a. I get negative 2 over 2, which equals negative 1. So that is my x of my vertex. Now, how to find y? Vertex is x comma y, right? So what we actually are going to do for this, we're going to take negative 1, plug it back in here for y, and find what y equals. All right, so y equals negative 1 squared plus 2 times negative 1 minus 3. And we're just going to solve algebraically. Check to see what you get. All right, I'm not going to show the work too because by now you should be able to evaluate. We get negative 4. So my vertex is negative 1, negative 4. And my axis of symmetry is always through the x-coordinate of the vertex, which is x equals negative 1. And that's important because it's going to help us graph later, actually. All right. All right, so what I want you to do is to pause the video and try the next two. I will show the work for you, but I want you to try them yourselves first. All right, check your work for the next one. I found my x, which is negative b over 2a. X became 2. I plugged 2 in to get my y. Y is negative 7. Axis of symmetry is x equals 2. You'll see the next slide when we actually graph. And try the last one. Pause the video until you solve it and see what you get. And check the last one, letter C. Be careful, your B is 0. Excuse me. A is 2, there's no X, so there's no B, which is 0. You get your vertex is 0, 1, axis of symmetry is x equals 0. Make sure you could solve that on your own before you move on. Now, maximum or minimum functions. First of all, let's find our vertex for each of them. Here's my vertex and here's my vertex. And this one, because it opens up and it continues going on the up direction, this is a minimum. This one's a maximum. And it all deals with the vertex. The little vertex here would be vertex is lowest point on the graph. A maximum for here, vertex is highest point. So we try to do max or min. Min is when the graph opens up, it's a positive A. When at maximum, it opens down, it's a negative A, because the graph keeps continuing on in the down direction. All right, so now what we're going to do is sort of put all this to use to find out how to solve and graph them. All right, so let's just continue on here. The last 3 examples we have are sort of putting it all together with what we've learned so far with graphing quadratics in standard form. So let's start, determine if it's up or down. All right, well, what's my a? My a is in front of the x squared. So a equals negative 1. So it opens down, all right. Next one, find your vertex. We know, and just in case we need this, we'll write off the side. A equals -1, B equals -5, C equals -2, right? Just so we're aware of everything. Find the vertex. We have x equals -b, so it's -5 divided by 2 times a. My a is -1. So it's 5 divided by -2 equals -2.5. All right. How we find the y? We know we plug it back into the original. Be careful with this equation because that negative outside is actually not part of the x with the number. Like -2.5 goes in here. It's the negative outside. So just be careful of that when you're solving. Oops. Your y should actually be 4.25. So my vertex, and I'll write it down here, is -2.5, comma, 4.25. So let's plot that point. -2.5 is roughly here, and 1, 2, 3, 4.25 is roughly here. That's my vertex. Now, I'm not going to label what the axis of symmetry is unless they really want it. My axis of symmetry is through the x-coordinate of the vertex, which is -2.5. So you see I'm drawing that dotted line. And the whole time, it's an axis of symmetry because of the fact that a parabola is symmetric. And that's actually going to help us to get one of our points today. So here's my vertex, right here. All right. Now, plot the y-intercept is next. My y-intercept is my c. And if we look up here, c equals -2. Now, it's the y-intercept along the y-axis, so -2 along the y-axis is here. Now, this really isn't a part to it, but what we have to do with a parabola, we need 3 points. Right now we have 2. We need at least 3 points to make a parabola. So it's going to deal with what we have already and the dashed axis of symmetry. So I know it opens down and it's a U shape. If I'm 2.5 spots roughly here, I'm going to go 2.5 spots in the opposite direction of the axis of symmetry. All right, so that line is very, very important to know in what direction to go. I have a point already to the right. I need a point to the left. And actually, that's it for graphing. You connect them. And hopefully your problem looks a lot better than mine here. But you get the idea. Now, make a small table. If I can actually graph 3 points, so remember, quadratics in this lesson, we want 3 points. I don't need a table, so it'll say if necessary. Now, the last part, max or min, all right, it opens down, so this is what? A maximum. My maximum is always going to be the y-coordinate of the vertex. So what do we get for y back in step 2? My y is 4.25, so we're going to write max at y equals 4.25. And that's it. So let's try another one. Now what I want you to do is actually, once again, and I keep saying this a lot throughout this lesson because I walk you through each part, but I want you to pause the video and try it yourself first. See how far you could get. I'll start by labeling everything up here. A equals -1, B equals 6, C equals -8. All right, so determine up or down. My A equals -1, so it opens down. It's a it's a negative A, so it opens down. Vertex, x equals -b over 2a is my formula. So -b, this time it was a +6 over 2a, 2 times -1. I get -6 divided by -2, which is 3. Once again, how you find your y, you just plug in 3 for x, back into the original. Be careful when I actually evaluate. If you guys notice, the negative once again is outside. It's not included with the x. And evaluate this. You should get y equals 1. So my vertex is 3, 1. So 1, 2, 3, 1 is here. And it says graph the vertex, which we did. Axis of symmetry is through x equals 3. Remember, it's always a vertical line. Remember that symmetric line breaks the parabola in half, and it's going to help us to graph our third point. So it's important that you draw it. All right, plot the y-intercept. My y-intercept is c. So c from up above is -8. All right. Along the y-axis, I go down to -8, plot my point. Now, how to do the third point? If I have 2 points already graphed, I could easily use this axis of symmetry to help me do my third one. I have a point, well, the vertex, I have a point to the left. I now need one to the right of the line. I'm 3 to the left, I go 3 to the right, plot it, and connect them. Remember, it's a U-shaped parabola. Hopefully, like I said, this graph is a little bit better, but hopefully your graph's better than mine. It's more like you. I had 3 points, and I was able to plot my parabola. So I do not need the table here. And let's take a look. Because it opens down, it's a maximum. My maximum is at the y. So we're going to write max at y equals. Remember, it's the y coordinate of the vertex. Max at y equals 1. All right. So here's our last one. One more example. All right, so for example 6, once again, let's label our a, b, and c. A equals -2. And take a look here. I don't have a b, right? Do you see how b would be attached to the x to the first power? There's no x to the first power, so it's 0. And c equals -5, all right? My a equals -2. So it opens down because it's negative. My vertex. I use -b, so -0, divided by 2 times a, or 2 times -2. So I get 0 divided by -4, which don't forget is just 0. So I plug 0 back in to the original. My y will just be -5. So my vertex is 0, -5. So graph vertex axis of symmetry 0, 1, 2, 3, 4, 5. Here's my vertex. Axis of symmetry. Draw your dotted line through it again. Now, let's move on to my second point. All right. The y-intercept, c equals -5. All right. So let's plot c equals -5. It's down 5 spots in the y-axis. What do you notice here? If I plot my y-intercept, it's here, right? So here's the issue. How many points do I have? I only have 1 technically, right? Because they overlap, they're the same thing. I don't have a second point to mirror image to make symmetric based off the axis of symmetry. So actually what I have to do is finally make a table. So if you were wondering that whole time, what does she mean by, make a table? It's because the only time you need it, and I'll be honest with you, when do you need it? Do you see how b is 0? If b is 0, you're going to need to make a table. So let's see if I could do this here. Let's see x and y. Now, I always graph, I said, a parabola at least 3 points. Even when we did a table earlier on, we had 3 points. You could do more if you want, but a minimum of 3. So I'm going to go based off of the line here. I'm going to pick what? -1 and +1. And I'll move this up here. So pick 2 points. If I plug in plug -1 back into the original, like in earlier table 1, I get -7. And if I plug in 1, I get -7 as well. So that's actually my little table. So -1, -7 is here. 1, -7 is here. So here's my parabola. So when do you need to use a table? When b equals 0. If you have a b, the vertex and the y-intercept will not be the same. But if b is 0, y-intercept and the vertex will be 0. Now last part, max min. Once again, it's a min. I know I gave you all the examples with minimums. Remember, if it was positive, it would be max, but it opens down, so it's, oh, excuse me, actually, I said that wrong. It's a max. I gave you problems with all maximums. If it was a positive 8 and opens up, then it would be a min. So you still get the idea. Max at y equals -5. And that's it. All right, so homework, because this song was lengthy, I'm just having you do the problem of the day, and we'll get to the problems to do the rest of the practice. That's it for today's lesson.